Hi, my name is Lola, and I'm a senior at the University of Chicago. And this summer, I worked with the amazing team at Parallelworks. And so today I'll be talking about synergies or intersections between Parsl, MLOPs, and custom cloud clusters. And so what are MLOps? Machine learning operations help with the automatic deployment of machine learning softwares. So for example, listed here you have MLFlow, which helps with tracking experiments. And so it tracks different things about the experiments, like the model, the data, the loss, or each run of the experiment, different things like that. DVC, or data version control, helps you to store different things at different points in time, specifically for big files. So for example, the different model at different points in training. And so it can help you, because GitHub can't store as, you can't push super big files to GitHub, so you can use DVC in that area. And then you could go back at each of these points at different times to train the model with different methods from certain points or things like that. And then for TensorFlow, it helps with model development and training. And so the point of our work this summer was to figure out how to get all of these things to be up and running and working together to create sort of like an ecosystem of sorts where all things are eating and storing the same data from each other. And so what businesses and industries such as Parallelworks do is to commercialize this process. And so essentially a company serves the customer. And in most cases, this is an iterative process. And so companies need to respond and adapt to new and incoming data. So for example, with a weather model, you get new weather data multiple times a day, and it would not be productive to retrain the model from scratch every time this happened. And so with MLFlow and DVC, you can retrain in a more efficient way. And because all of the things that you need are saved, and you can continue from a specific point in time. So having MLOps on a custom cloud cluster has a bunch of different benefits, as listed here. Again, such as collaboration, portability, and transparency, or being able to use different types of clusters and computers for different aspects of the process. So for example, using a CPU for pre-processing data and a GPU for training, which could help keep the cost performance ratio lower. And so the point of this talk is to show how using Parsl brought about new and interesting things about MLOps and custom cloud clusters, and to show how they all interact with each other. So first we'll talk about the intersection of MLOps and Parsl. And we did this by making each machine learning operation a Parsl app and making a lot of them dependent on each other. So for example, making the directory that saves the files that are with information on the model, pre-processing data, saving things to DVC, and starting the Parsl visualizer and the MLFlow server can even be put onto an app. And again, here you can see the data or the code for the model building and the training being put into a Python app. And so things like doing logs on what's happening when and where during the process, or compiling the model, or auto-logging with MLFlow, or starting doing different runs of the experiments with MLFlow can all be done inside the app. I would also like to highlight that the portability aspect that I was talking about earlier. And so this work that I'm presenting is portable and runs end-to-end on any cluster. So anyone could try it if they would like to. And so here we can see the intersection between MLOps and custom cloud clusters. And so this is just an example configuration, and the workflow I've been talking about ran on a more simplified configuration. However, the main point here is that because we can customize cloud clusters, that gives us a lot of flexibility in choosing how the workflow operates. So like I was saying before, sending certain things to CPUs, such as data processing, or training to GPU nodes for helping with costs and stuff like that. And then finally, we have the intersection of Parsl and custom cloud clusters. And so these screenshots are through the ParallelWorks platform and show an example of using the workflow on a cluster through the platform. So this is just good because all these things can be easily accessible in one place. But here you can see the cluster that is needed for to run the workflow, and also like the storage buckets for things like DBC storage and data storage. And again, the Parsl visualizer and MLFlow are displayed on the cluster, so you're able to see them here. Like before the loss during training as tracked during MLFlow. And then this screenshot in particular is pretty interesting because it shows the DAG in the Parsl visualizer, and you can see all the dependencies that were specified in the workflow. So for example, this long line of dots is one experiment, and all the runs and retraining depend on each other. And this yellow dot is actually the execution of DBC, so the storage of like the weights of the model after it was done training. And so, as you can see, this cannot happen until all the training is finished, but it also cannot happen until DBC is set up. And so, which is this dot here. So those dependencies are shown here in the visualizer. And so some additional points and conclusions. Building MLOP workflows in Parsl enables scaling to a cloud. Parsl monitoring is great for debugging workflows because, again, of the mix of long and short running processes, and you can see the dependencies that are needed and where things failed and things like that. And Parsl's enforcement of app and data dependencies can control cloud costs, which just like before I was saying that the sending things to different types of nodes can help with the cost performance ratio. Things that Parsl does, like preventing training from running if prerequisites are delayed and forcing explicit treatment of data transfers, can also help control cloud costs. And so for future work, we could experiment more with GPU nodes, also federating multiple cloud MLOPs and integrating the new Parsl with ParallelWorks cloud cluster deployment.